Good morning. We are on lesson 9.3, and you're going to see in lesson 9.3 how we tie together what we've learned in 9.1 and 9.2. On your classroom, you should see a guided note sheet. You should see a sheet like this, which brings together all the core concepts we've learned in the first 3 lessons. And then you should have a piece of paper like this. If you cannot print this out, you don't have access to a printer, you just need to copy this drawing to the best of your ability. Get a big round thing, trace a round circle, draw a cross in it, and then divide these circles up into, this quadrant is divided up into a third first with this line, and then you sort of split the line in the middle, okay? All right, so 9.3, we're going to talk about trig functions in the coordinate plane. All right, so we're looking at the value of trig functions of angles whose terminal side intersects a circle of radius r. If you remember what the equation for a circle is, that is x squared plus y squared equals radius squared. And this one, it is centered at the origin because there's no shift right or left. All right, so say I have my circle right here. All right, each one of these lines along the x-axis here, or on the y-axis where it intersects the circle, these are all radii, right? From here to here would be a radius. All right, but any point from the center out would also be a radius. So given that, depending on where my terminal side is, so this is my initial side, this is my terminal side, I can use Pythagorean theorem to find the value of the trigonometric functions of the angle here without even having known what the angle is. That's what's really cool. All right, so say I have a circle like this and it intersects the circle here at this point, right? This is the point x comma y. We'll just any random point x comma y. Well, think about that. What that means. I'm gonna get a third color. Think about what that means in terms of coordinates, right? This length right here is x. And this length right here is y. Right, so we can find r by doing x squared plus y squared equals r squared and solving for r. So if we know a point, we can go ahead and find the third side because a point gives me the legs of a right triangle. So I'll say that again. A point on a circle centered at the origin gives us the legs of a right triangle. So let's do an example. Let's say that is the point -5, 12. All right, so then that means this length right here is -5, and this length right here is 12. I didn't leave room for examples on your guided notes, so I would go to a separate page or flip over to the back if you can to help you copy down some examples. So using Pythagorean theorem, I can find out what r is. So in this case, the length of this line is 5, right? The distance from here to here is 5. It's -5 because we're going left, but we can just say that it's not going to matter either way because we're going to square it. So I get 25 plus 144 equals y squared. So I get 169 equals r squared, sorry. So r comes out to be 17? 17 times 17. I'm just double checking my math here right now. 181, it's not 17, is it 13? Or is it, I better use my calculator here. What is the square root of you're all doing this, right? 13. So that last side is 13. Okay. All right, so now I have all sides of this triangle. So even though I don't even know what that angle is there, I can go ahead and calculate the sine, cosine, and tangent. So the sine here would be opposite 12 over hypotenuse 13. The cosine would be -5 over 13. The tangent would be 12 over -5. We can just write that as a -12/5. Now to find the other trigonometric functions, we're just going to take the reciprocal. The secant is the reciprocal of the cosine, so -13 over 5, and the cotangent is -5 over 12. All right, so that's how we can use the unit circle to find the trig functions of an angle given its initial side on the x-axis. All right, so we want to do a few more examples. We're going to do the point 4, -3. That one is on your review sheet. So again, I'm going to draw my coordinate plane. I'm going to draw the point 4, -3. So let's go here. All right, there, if I were to draw a radii from here to here, first you can see the right triangle I can draw there, okay, with the terminal side. You can also see that I can draw a circle from that point, right, all the way around, so that that line that I drew out to the point there is the radius. All right, so the length of this line right here is 4. The length of this line is 3, but we're going to put a -3 to remember that we are in the 4th quadrant. All right, so if I do Pythagorean theorem, though, that's just length. So we're just going to go 4 squared plus 3 squared is 16 plus 9. So we have r squared equals 25. So we get r equals 5. So we have our 3, 4, 5 right triangle, and now I can evaluate my trigonometric functions for this angle right here. All right, so we are going to figure out that sine is -3 over 4. Cosine is 4 over 5. Sorry, this should be -3 over 5. Tangent would be -3 over 4. and then I just take the reciprocals. All right, an interesting thing about this problem, and maybe some of you already thought of it and maybe you hadn't noticed it, was that how did I know what angle here to make? I'm just going to use the angle that makes the right triangle with the line from the origin, okay? All right, let's do another example. Let's do one that isn't one of our special right triangles. So let's try the point -1, -3, okay? Oh, I just wrote up, I'm writing all over my stuff, that's not good. Are you gonna go get me a wet cloth? All right, let's try it again. Let's go to the point -1 down -3. All right, so this distance from here to here is 1. This distance from here to here is 3. I'll put it over there. And I can draw a radius there. And then I can draw a circle around here, like so. All right, so if I look at this right triangle here, it has sides -1 and 3. So if I want to solve for r squared, it has length of 1 squared plus 3 squared. So 1 plus 9, so I get r squared equals 10, r equals the square root of 10. All right, so that hypotenuse is the square root of 10. So we can still go ahead and calculate our trigonometric functions here. Just getting that cleaning off, or I just wrote on my wall here. I don't want blue marker on my wall. Okay. All right. So our sine here, if my angle is right in here, is theta is right in here, the side opposite of that would be 3. So 3 over the square root of 10. If I multiply both sides by top and bottom by square root of 10 to rationalize the denominator there, I get 3 square roots of 10 over 10. All right, cosine would be adjacent over hypotenuse, so -1 over the square root of 10 would just equal negative square root of 10 over 10 if I rationalize the denominator. All right, tangent would be 3 over -1 or -3. All right, and if I take the reciprocals here, I get square root of 10 over 3, square root of 10 over -1, which equals negative square root of 10. And for cotangent, I get -1/3. All right, so that given, so what did we start with? We were given, you can see up right down here, we are given a point. All right, what's the second thing we did? We drew an angle with initial side on the x-axis and terminal side at the point. All right, then we use Pythagorean theorem to find the radius. And then we could calculate the trig functions. Okay. All right, we're going to look at a special case now where we're going to define that circle to have radius of 1. All right, we're going to define that circle to have radius 1. If you need to still copy that, pause the video, please, and copy it down, and then come back. All right. So I want you to draw another coordinate plane. This time our circle's radius isn't given by the point, but we're going to define what the radius is. All right, so we're saying this circle has a radius of 1. That circle, it has a special name, and it is called the unit circle. All right, x squared plus y squared equals 1. So I want to think about the trig values on a circle, on any point on this circle. All right, so particularly let's look at the cosine and sine of any point on the unit circle. All right, so I'm just going to pick a point right here. All right, so if I pick a point right here, I can make it be a right triangle again. All right, if this has coordinates x, y, we don't know what x is in this case. We know that you go over x, so this bottom sign is going to be whatever that is. You're going to go up y. But I know that this line right here, by definition, is a radius, so that is equal to 1. All right, the hypotenuse is 1. All right, so let's think about what cosine is. Cosine is adjacent over hypotenuse. In this case, this is our theta down here. The adjacent side is x, so I get x over 1. For sine, I get opposite over hypotenuse. So in this case, I get y over 1. Well, those simplify down to be just x and y. So on a unit circle, think about this now, the x value equals the cosine of the angle formed. And this y value equals the sine of that angle formed. So we can write this. For any point on the unit circle. So for any point on a unit circle, the x coordinate represents the cosine of the angle, and the y coordinate represents the cosine of the angle. All right, so let's think about that. Let's think about that if we have a unit circle here. Okay. And we're thinking in terms of degrees, right? So this would be 0 degrees, 90 degrees, 180 degrees, and 270 degrees. Well, we also know some points here, right? If this is a unit circle and this is radius of 1, then this is the point over 1 up 0. This is the point over 0 up 1. This is the point over -1 up 0. And this is the point over 0 down -1. So interesting enough, now we can say what the cosine of, this is also right 360 degrees, of any of these angles are. So if I asked you what is the cosine of 180 degrees, you would know it is -1, because this number represents cosine of the angle, 180 degrees, and this represents sine. All right, if I asked you to find the sine of a 270-degree angle, I would make my angle 270 degrees, comes around to here. The coordinates at this point are 0, -1. This is cosine, this is sine, so the sine at positive 270 is -1. All right, we could also do the same thing with, if we, instead of degrees, we had radians. All right, so say I still have my unit circle, all right, with radius 1. If we're thinking in terms of radians, this is pi over 2, this is pi, this is 3 pi over 2. All right, so if we needed to find the, let's go with all 6 trig functions for pi over 2. All right, so we're going to look at the sine of pi over 2, the cosine of pi over 2, tangent of pi over 2, cosecant of pi over 2, secant of pi over 2, and tangent of pi over 2. Equal signs getting a little messy there. All right. Before we do that, I'm going to show you another relationship. So we know that cosecant, right, is 1 over sine. Secant is 1 over cosine. Tangent is, what is tangent? That's what I want to show you here. So tangent is equivalent to sine over cosine. All right, so if you look up here for a minute, I'm going to show you that. All right, we define tangent as being the opposite side over the adjacent side, correct? What would be we get if we do sine over cosine? Or if we do sine over cosine, we get opposite over adjacent, opposite over hypotenuse, and adjacent over hypotenuse. In other words, opposite over hypotenuse divided by adjacent over hypotenuse. If I flip that, change division to multiplication, take the reciprocal of the second fraction, hypotenuse cancels out, and I get opposite over adjacent. All right, so that tells me that tangent is the same thing as sine over cosine. All right, that's going to help me down here with my unit circle here. You are going to pi over 2, right? The first number is cosine, so we could say the cosine of pi over 2 is 0. The second number is sine, so sine of pi over 2 is 1. Tangent is going to be sine over cosine, we said above, so I get 1 over 0, undefined. There is no tangent of pi over 2. Cosecant is 1 over sine, that's 1. Secant is 1 over cosine, again undefined. And this should say cotangent of an undefined. So remember, this was supposed to be 1 over 0, and we said that was undefined, but in cotangent that would be 0 over 1, so that would be 0. Okay? All right, I think I've given you plenty of examples. Your homework is to make a unit circle. You can look at I will give directions for that, okay? And to complete a few problems in your book. Thanks. Bye.